So I'm going to try and fix this. All right. Okay, so, and think of this as a balance scale. So if I rewrite this and I add 2 to the left side, so if you put 2 on the left side of this balance, what must I do to the other side? Add 2 as well. Okay, so what you add to one side, you have to do to the other. All right, so whatever you add or subtract from one side of an equation, you have to do to the other side as well. Okay, and so that is called the addition property of equality. So let's talk about the addition property of equality. All right, so the addition property of equality says this: if A equals B, if A equals B, and I add C to the left side, then what must I do to the right side? Add C as well. So A plus C must equal B plus C. All right? So it's kind of like if I had 2 equals 2 and I subtract 7, then I must do what on this side? Subtract 7. Now, notice that the property only says the addition property of equality. There is no subtraction property of equality. So even though you're subtracting here, it's still called the addition property, because remember in a previous course, you can always change subtraction to what kind of operation? Addition. All right, subtraction, you can always change to an addition problem. So remember, let's just look at 4 subtract 8. So remember how to, in a previous course, how to change the subtraction? So you change that to an addition problem. So we have 4 plus, and then what does this become? A -8. So remember, you got to add the opposite. All right, so that was from Math 97 or so. That was last semester. So when you read this, this is read as a +4 subtract a +8. And so to change this to an addition problem, you say a +4 plus the opposite of a +8. What's the opposite of a +8? A -8. All right, so you can either add or subtract a number from both sides. It's still what property that you're using, the addition property of equality. Okay? All right, so let's look at some examples using the addition property of equality. We're going to look at the simple ones first, and then we go to the next property, and then we'll come back and we'll do a mixture of those two. So this is going to be number, let's say number 1. So this is on page 630. Number 1. All right, on the worksheet, when you look at the worksheet, let me go ahead and give you that so you'll know what it is I'm talking about. All right, so if you look at number 1, you have x plus 7 equal 10. All right, so I'm trying to get the variable x by itself. Now you can look at this number, the answer. What number plus 7 is 10? 3. All right, but if all you do is just put 3 in the blank, you're not going to be happy. All right, here's what I want. I want you to show me that you're using the addition property of equality. I'm trying to get the variable x by itself. Right now, what am I doing to x? No, not yet. Answer the question. Listen to the question. You're right. That's what you're going to do, but you're not answering the question. Right now, what am I doing to the variable x? What? No.
Solving for x?
Yeah, that's what I want to do, okay? I want to solve for x. What I wanted you to say was, when I said, right now, what am I doing to x? I want you to say, I'm adding 7. That's what this says, right? I'm adding 7 right now. So you want to do the opposite. What's the opposite of adding 7? Subtract 7. So here's the step you're going to show. Subtract 7, subtract 7. That's the step. So you're using the addition property of equality. What you do to one side, you do to the other. All right. Now, remember, you're trying to get the variable x by itself, right? So you got to think of opposites. So there are two things that should be opposite of each other so they come out to be 0. And they are. A positive 7 and negative 7 are opposites, correct? So when I add them up, when I combine like terms, I get what? 0. All right, now notice though, now most students will do it vertically like this, minus 7, minus 7. You could also do it horizontally. So you're going to say minus 7, minus 7. But you understand that those two are the same thing. God, this thing's blurry. All right, so those two are the same thing. Hold on, I got to fix this. All right, so somehow this thing became blurry. All right. Okay, so you understand those two are the same thing? All right, most students will do this though. They're going to do this vertically. Now remember, on one of your worksheets, you had this. See this right here? Now, again, I didn't ask you to show the work, but if you were to show the work, what would you have to do here? Distribute. So you say negative 12x, and then what's negative 4 times 7? Negative 28 and minus 5, right? So you see this part right here? That kind of looks like this, right? So what did that person have to do with these constants? Combined them. A negative 28 and a negative 5 is a negative 33, and that's how you get that answer. So if you do it horizontally or vertically, that's what you're doing. You're doing this idea right here. So you got to compare this to what you've been doing. And so what's a positive 7 and negative 7?
0.
And so what's x plus 0? X. And what's 10 minus 7? 3. And same thing here. What's a positive 7 and negative 7? 0. And what's x plus 0? And what's 10 minus 3? 3. Okay? So that's that one step. So the one step you have to do is show that, in this case, subtract 7, subtract 7. Okay? And then in the blank, you put 3 as the answer. So all you have to do in the blank is just put 3. Just put 3 in the blank. Okay? All right, but you got to make sure you know what I mean by that one step. That one step.
You want just the number or x equals 3?
It doesn't matter. You can just put the number there, the solution. So the solution is 3. There's only one variable. So now next semester, you're going to have 2 variables to deal with when you solve systems. So there you have to be a little bit more specific. All right, so if you look at number 3, you have x minus 2 equals negative 4. And let's just go ahead and do it vertically. So I'm trying to get the variable x by itself. Right now, what am I doing to x? I'm subtracting 2. What's the opposite of subtracting 2? So I'm going to add 2 to both sides. So you're going to say plus 2, plus 2. You got to show it on both sides. If all you do is show one side, you'll be upset because you got to remember what you do to one side, you have to do the other. You got to show that. It's a balance. And now we're going to use the idea of combined like terms, just like we did in that example a while ago. So a negative 2 and a positive 2, those better be opposites because you're trying to get x by itself. So what's a positive 2 and a negative 2? Yeah. So what's left on this side? X equal. And what's a negative 4 and a positive 2? Negative 2. Okay? All right, so that's number 3. All right, and then number 5. Number 5. You have negative 11 equal 3 plus x. Now sometimes the variable is going to be the right side. It does not matter. Either you can say x equal the number or the number equal x. It does not matter. Now on the number 5, on the right side where the variable is, sometimes students get a little confused when it's 3 plus x because they're so used to it looking like x plus 7 where the variable is listed first. See that? The variable is listed first here, right here. here the variable's listed second. We're saying 3 plus x. It doesn't matter. You can leave it like that. Or if you want to, since this is an addition problem, how else can you write 3 plus x? You have to do that on one of the worksheets. Either you turned in or you got back. Say that again? X plus 3. All right, so all those things you're learning, you can use in these as you go along. Everything is cumulative. They build upon each other. So if 3 plus x cause you an issue, then rewrite it as negative 11 equals x plus 3. All right, either way, it does not matter. For some students, this is easier to deal with right here. Right now, I'm adding 3 to x. What's the opposite of adding 3? Subtract 3 from both sides, right? So that's your one step. And so now these are opposites, so when I add them, I get 0. So what's left on the right side? X. And a negative 11, negative 3 is a negative 14. Over here, you would do the same thing. Look what you have. You have, to this x, I'm adding a positive 3, right? So the opposite of adding a positive 3 is to add a what? Negative 3. So in other words, I'm going to subtract 3. You see this? 3 to negative 3 is what? 0 plus x is x equal negative 14. Okay, it does not matter which approach you use. Okay, number 7. Sometimes you have decimals. In that case, you may want to use your calculator for those. So what is that one step you're going to show? Was that one? Say it again.
Addition.
Okay, but tell me that step. You're gonna do what? Add 8.6. You're gonna add 8.6 to both sides. So it's gonna look like this. This is what you're gonna show. Another thing that some students do, and you can get upset with me. Let me show you what some of you are gonna do. You're gonna say this. Well, that doesn't tell me anything. There's nothing in front of that 8.6. What do you have to put in front of the 8.6? The plus symbol, the addition symbol. So don't do that. Okay, so don't write it like this. You got to tell me what you're doing. Either I'm adding 8.6 or I'm subtracting 8.6. All right, so don't write it like this. You must have an operation here. Must have an operation symbol. All right. Okay, so combine like terms. Remember the phrase combine like terms. You're going to be using that quite often. Combine like terms. These are opposites. They're supposed to be opposites. So when I add them up, what do I get? All right, and so r minus 0 or r plus 0 is the same thing as r. Now on your calculator, what is negative 8.1 and positive 8.6? 0.5. All right. There's our 7. Okay, and number 9. Let's suppose you had x minus 2/5 equals a negative 3/20. X minus 2/5 equals a negative 3/20. All right, so what are you going to do to both sides? Now again, what property am I using when I add or subtract? What's that property called? Addition property of equality. Addition property of equality. So what I add or subtract from one side, I do to the other. So what are you going to do to both sides? What's that one step you're going to show? Add 2/5. So you're going to add 2/5 to both sides. And then we're going to combine like terms. A negative 2/5 and a positive 2/5 is 0. So what's left on the left? And that's what you want. You want to know what x equals. All right, so you can use your calculator with this. So you would say, remember how we do this, you would say negative 3/20, negative 3 divided by 20, and I'm adding 2 divided by 5. And when I do that, press equal, I get this. Now it's 0.25. Most of you already, based on what y'all did last semester, all of you better know what 0.25 equals or 25/100ths equal. What fraction does that reduce? 1/4. Very good, 1/4. If you didn't, Hopefully it's none of you. But if you could not remember that, then you're going to press what here? Second, and then PRB, and then press equal and get 1/4. Okay? All right, now, if for some reason you use your calculator, let's do this a long way. So we have negative 3/20 and a positive 2/5, correct? So if we do it without a calculator, what's the LCD? 20. So the smallest number that 20 and 5 go into is 20. So I'm going to write two fractions with 20. And then I'm going to write equivalent fractions now. So remember the word equivalent fractions. So basically you're asking yourself, negative 3/20 is equivalent to what fraction with 20 as the denominator? Well, they're the same denominator, right? So negative 3/20 is equivalent to itself. So what's going to be here?
-3.
Okay. So 2/5 is equivalent to what over 20? Well, to do that, you're going to ask yourself, I need this to be a 20, correct? Well, right, it's a 5. So my factor's a 5. So I got to think, well, 5 times what is 20?
4.
Okay, but what I do to the denominator, I have to do to the numerator, so that's going to be 8. So I just did equivalent fractions. So these are equivalent fractions here. So now you just, remember fractions, so you have, let's say these were candy bars. Well, not candy bar because it's negative, but let's just say these are partitions. So these are 20 partitions. You have a negative 3 of them here. You have a positive 8 of them here. So altogether, how many do you have? 5. So that's 5 over what though? Reduce, what's this? 1/4. Okay. All right. So, any questions on those? All right. So that's the addition properly. That's that one step. So that's what you're going to do on these worksheets. Okay. Let's see. Oh, okay. All right. Let's look at. Okay. All right. So let's look at this one. You can do 1 through 4 right now very easily. Let's look at 5 through 8 for the moment. All right. So let's look at this example. All right, so this is going to be number 37. Number 37. Okay, number 37, you have 13x minus 3 equal 14x. All right, so 13x minus 3 equal 14x. All right? So this is still going to be that one step. There's only one step you got to do here. But I want you to notice that in this case you have variables on both sides. You see that? Okay. So here where I had the constants on both sides, see the constants? I had constants on both sides, right? So I was getting the variable by itself. So in this case, since I was subtracting 8.6, I'm going to add 8.6 to both sides. Here I have variables on both sides. So what you want to do is bring the variables to the other side, to one side. It does not matter which side you bring it to, but be strategic. See, this is 13x. This is 14x, right? What's this coefficient right here?
13.
What's this coefficient?
14.
All right. Which has the larger coefficient?
14.
All right. So what you're going to do is get rid of this 13x here. So you're going to get negative 3 by itself. All right. So remember, I'm trying to get 13x out of here, right? So always think like this. All right. So either I'm going to add or subtract. Is adding 13x going to help me?
No.
All right, so I want you to think about this. Suppose you did do that, and then see if it makes any sense. So add 13x, add 13x. Now mathematically that's correct. What you do to one side, you do to the other, correct? So could someone have added 13x to both sides and still be mathematically correct?
No.
Yes. Yes, you could have. But it's not going to help you. What you do to one side, you do to the other, right? So if I add 13x to one side, then what must I do to the other side? Add 13x. Exactly. But mathematically, this is still correct. Yes or no? Yes. But that's not going to help me to get the variable by itself. Because when I do this, this is 26x minus 3 equal what? 27x. Has that helped me at all? But mathematically, that's still correct.
You can still get your answer though.
What now?
You can still get your answer.
Yeah, you can still get the answer. Yeah,
26x minus 27x.
say it again.
It will still give you the answer.
That will still give you the answer. What would you do though?
Subtract 26 minus 27x. It'll give you 1.
Yeah, so what she's saying though, and you need to make sure you show that step. She's saying even though someone did this right here, which mathematically is correct, and they get this, she's saying, well, even though they did this, I can still get the answer for x just by subtracting 26x from both sides. Is that correct? Yeah, because what's 26x minus 26x? What's left on the left? And what's this right here? 26x minus 27x minus 26x x. But so you kind of went the long way though, right? That's not what you want to do. You want to do that one step if at all possible. So instead of adding 13x to both sides, I need to do what? Subtract 13x. And then 13x minus 13x is 0. 0 to negative 3 is a negative 3. And what's 14x minus 13x? So you get the same thing. It's just that this is a lot quicker. Okay? All right. Let's look at, let's see. Let's do 39. All right, so this is 39. Okay, so 39, you have 5b minus 0.7 equals 6b. So it's very similar to the one we just did. All right, so what are you going to do? The quickest, the more efficient thing to do right now is to subtract 5b, right? Adding 5b, even though it's mathematically correct, adding 5b to both sides is not going to help me right away because these b's, I still have b's on both sides. So subtracting 5b is the one that's going to help. So what's 5b minus 5b when I combine like terms? 0 minus 0.7 is negative 0.7. 6b minus 5b? 1b. So there's your answer. Okay, let's do one with a fraction. Suppose you had all right, so I'm going to go ahead and make that one up because I don't see one in here. All right, so let's go ahead and make this one up. All right, suppose I had this. This will be example. Suppose I had, let's make this denominator a 5. And let's say this up here is a 7. So I have 7 fifths x. So 7 fifths x plus 4 equal, and let's make this 12 fifths x. All right. Okay, so I have variable on both sides. What would you want to do to both sides? Which subtract what? 7 fifths. That's the more efficient thing to do. Subtract 7 fifths x from both sides. Because if you look at the coefficient here, that's 7 fifths, right? This is 12 fifths. Which one's larger? 12 fifths. So you can subtract 7 fifths from both sides, 7 fifths x, and then combine like terms. 7 fifths x minus 7 fifths x is 0. 0 plus 4 is 4. And then here, the denominators are the same, so that should be easy for you. What's 12 fifths? 12 fifths, subtract 7 fifths. But it's 5 fifths. You're right. It's 5 fifths, right? Which is what? 1. So therefore, what is 12 fifths x minus 7 fifths x? Just x. Okay, so that should take care of this worksheet. So you should be able to do this at this point. All right, now that's only part A. You don't have part B yet. Part B is going to involve this other stuff that's in there. Okay, but this is part A. You can do part A. So when's part A due? Thursday, right? Okay. Now that was the addition property. Okay, let's talk about this. Okay, suppose we had this. Suppose I had 4 equal 4. Y'all agree that that's a true statement, 4 equals 4? Okay, so that's a true statement. So if 4 equals 4, then what if I did this? Let me go ahead and rewrite this over. What if I multiplied this 4 that's on the left side by 5? Yeah, because that's a 20 now, right? So if I want that to still be a true statement, then I better get a 20 on this other side. So I've got to also do what to this other side? Multiply that by 5 as well. So if I'm a while ago, if you add or subtract something from one side, you have to do it to the other. Here I'm multiplying a side by a number. I got to do what to the other side? Multiply that as well. Okay. I could have also done this. 4 equals 4. So I could have said divide by 2. So if I divide the left side by 2, I've got to also do what? Divide the other side by 2. So let me go ahead. So basically it was this. If 4 equals 4, then 4 divided by 2 has to equal what? 4 divided by 2. So just like when we talked about subtraction, remember there is no subtraction property of equality. There's only a what? Addition property of equality, because you can always change subtraction. What kind of operation? Addition. So just like the addition property, this right here is called the multiplication property of equality. There is no division property of equality because you can always change division to what kind of operation? Multiplication. All right, so the multiplication property of equality. All right, multiplication property of equality. And so basically it says this. If A equals B, if A equals B, and if I take A and I multiply it by C, if I take the left side, multiply by C, then I've got to do what to the other side? Multiply by C as well. Okay? So if A equals B, then A times C must equal what? B times C. So basically all it's saying is that if you multiply or divide one side of an equation by a number, you have to do it to the other side. To the other side. All right, so if you multiply or divide one side of the equation by a number, and I got to be a little bit specific about that number. By a number, then you have to do the other side. So you can multiply, divide by any number except 0. You can never use 0. All right, can never use 0. So except 0. Okay?
Must be a zero property.
No. Yes.
So why are you using C?
Say it again.
Why are you using C?
The same reason I use C with this one. A plus C equal B plus C. I'm just using a letter.
Oh, okay.
Okay? It's just a letter.
In the place of the 1.
No, that's not a 1.
Okay.
I'm just saying the letter A I can multiply by any other number. We don't know what that number is. I'm going to call it C.
Okay.
Okay? All right. So you cannot use 0 because if I divide by 0, if I take something and divide by 0, 5 divided by 0, remember from last semester, that is what? Undefined. Okay? So everything you've learned last semester and everything you learned here applies for the next section. So all this stuff is cumulative. So these are all prerequisite skills, what you did last semester to now. Okay, so except 0. All right, so let's look at now I'm going to go ahead and give you the worksheet for that one So to show you what it's going to look like. So this is going to be number, let's just do this for example for right now. So let's solve, let's say we had 7x equal 35. 7x equal 35. You can look at that and tell me what the answer is. 7 times what's 35? 5. Okay? But I need to see that step. So I'm trying to get the variable x by itself, correct? Right now, what am I doing to x? Nope. I am multiplying it by 7. I'm doing the same thing I asked y'all earlier. The very first problem, say, what am I doing to x? And y'all didn't understand what I was asking. So same thing here. What am I doing to x right now? I am multiplying by 7, right? So think the opposite. What's the opposite of multiplying by 7? Divide by 7. So you're going to do this. Let me go ahead and rewrite this over. So you're going to say divide by 7 and do what? Divide by 7. So what I do to one side, you're going to do to the other. Now, look at what you have. 7 divided by 7 is, nope, answer my question. Nope, 1. Anything divided by itself is 1. I got to bring some multiplication cards in here and some addition cards. 7 divided by 7 is 1. And what some of you do, which kind of goes back to why some of you are saying 0, is because when we did this, we crossed this out, right? But notice, I didn't just cross this out here. What else did I put? A 0. Because that's what it is. So positive 7, negative 7 is 0 here. Here, you have a habit of doing this without even knowing what that is. When I do this, that's not a 0, that's a what? A 1, because 7 divided by 7 is 1. And then 1 times x is x, just like x plus 0 is what? X. 1 times x is what? X. Okay. Equal, and what's 35 divided by 7? 5. So the step you have to do is just show divide by 7, divide by 7. All right? Now, don't make it a habit of just crossing this out and not putting something there. When you cross this out, it's really a 1. That's a 1 right there, and 1 times x is x. All right, so let's look at number 1, and this is on page 639. You have negative 5x equals a negative 20. Trying to get x by itself. Right now, what am I doing to x? Multiplying it by what? What's the opposite of multiplying by negative 5? Divide by what? Negative 5. Not positive. Not positive, because that's not going to get you that 1. Think about it. And if you make that mistake, I want you to look at this, and some of you will. You're going to make that mistake. You're going to do this, divide by 5, divide by 5. Well, that's not, mathematically, you can divide by 5. Nothing wrong with that, but it's not going to help you with what you want to get right away. Because what's a negative 5 divided by 5? That's a negative 1. Not 1, a what? Negative 1. So you got to put a negative 1 there. And the negative 1 times x is a what? Negative x. And we're going to look at something like this in a little while. So what confuses people is when they don't do this correctly right away. Although it's mathematically correct, I can divide by 5. It's just not going to help me to what I want. And that's going to be negative 4. So you're going to say the answer is negative 4, and it's not. The solution is not negative 4, it's a positive 4. So in a little while, we're going to look at, well, what do you do when it's a negative x? So let's go back and do this. Yes?
Are you going to take our points if we don't do the negative 1 at the top? Like,
If you just do this,
yeah, like, you know how you, just the like we divide negative 5 and get a positive 1. Are you going to take off but not having a positive 1 in our steps?
I would prefer that you put it there because that's what it is. Okay. Guys, mathematically, what should you be doing? Okay? All right. I'm sorry? What was that? Okay. All right. So what should I be doing here? Divide by -5, right? So -5 divided by -5 is a 1. How difficult is it to put a 1 there? Well, now you know it was wrong, right? You understand? You now know it was wrong. Okay? So mathematically, this is a what right here? A 1. You should never just cross something out without indicating what's left there. Okay? You can't put 1x, but mathematically 1x is just what? X. It's just x. I didn't say that, but mathematically what you need to understand is as you go, I know y'all trying to make fun of this, okay? But what I'm trying to get you to understand, listen to me. What I'm trying to get you to understand is as you go through your courses, you need to be efficient with what you're doing, okay? If you have coefficients all over the place, it gets a little confusing. So mathematically, crossing this out is something you should not do without indicating what it is. That is a 1. Now, when you write it over, write it as an x, not a 1x. Is that clear? I am telling you what's going to get you more success in your future courses. Because when you get to algebra, it's a different animal than this is. Is that clear? Okay. You're here to try and learn for the next course, especially college algebra, because you get no credit for this course. This is a remedial course. You get credit for college algebra. Is that clear? Okay. We'll leave it like that. -20 divided by -5. All right. Let's look at number. I'm sorry? A negative divided by negative is a positive. All right. Let's go to number 5. -x equal -12. All right. Now, you're trying to get x by itself, right? Okay. In the previous problem, you saw a coefficient actually listed. You saw a number listed. Now, for some students, it may be helpful to rewrite -x as what? -1x. Write it as -1x, because in your mind, that's what it is. But in your answer, when you solve for x, don't say 1x equal, say what? X equal in your answer, because that's what we prefer mathematically for you to write. That's how you need to understand how to write a solution. X equal, not 1x equal, but x equal. So to help you with this, it's a good idea to write this as -1x equal -12. And now what you want to do is get x by itself. Now we get x by itself, it's understood to have what coefficient? Nope. When you get x by itself, it's understood to have what coefficient? 1. All right, right now, what am I doing to x? Right now, what am I doing to x? Multiplying it by what? -1. Listen to the words. I'm multiplying by -1. What's the opposite of multiplying by -1? Dividing by what? -1. Okay, divide both sides by -1. Now, -1 divided by -1 is a what? 1. Don't say -1 divided by -1 is an x, because that's not true. -1 divided by -1 is a what? 1. Anything divided by itself is what? 1. 1 times x is what? X. And then what's -12 divided by -1? 12. So there's your answer. So when we did this one right here, I'm going to go back to the previous example. When we did this, you know how someone said divide by 5? Someone actually said that. And there's nothing wrong with that. But then I'm also thinking, and more times than not, they get the wrong answer when they do that. But now you know what to do here. So if you do divide by 5, and you cross this out like some of you would do and say, oh, I'm done, I'm cross this out, I don't have to put anything there, that's what causes you trouble. Because that's not a 1, that's a what? Negative 1. So if in your mind you're saying negative 5 divided by 5 is a negative 1, then you know that this is a negative 1x, right? And then how to get x by itself? Divide by what? Negative 1. Negative 1 divided by negative 1 is a what? 1. 1 times x is x equal 4. Okay, so that's how you would have finished that off. All right, but some of you are going to say, it's, because you want to think the opposite. The opposite of negative 5 is a positive 5. But that's fine. You can divide by 5, but you're going to have a negative coefficient there.
And if it just like leave the x alone and pass the negative 5 to the side of negative 20 and divide it just to that.
I'm sorry, say it again. Say it again. What would you say?
Like leave the x alone. Like
Leave the x alone?
Pass the negative 5 divided by negative 20. So you don't have
Okay,
to,
so I'm going to write the problem over. You're saying this right here, right?
yeah,
Okay, what do we need to do?
leave the x alone, like x negative 20 divided by negative 5 and just
Okay,
like the opposite.
so remember, you have to show that step. So what step must you show
Negative 5 divided by negative 5.
on both sides? Okay, you have to use the multiplication property of equality or the addition property of equality. It is true that this equals that, but you're skipping some steps that I want to see.
Oh, okay.
All right, the whole purpose of this section is for you to study the addition property of equality and the multiplication property of equality. All right. Now, when you get in college algebra, you can go ahead and skip some of those steps, but in here, in this course, you have to show that step. So don't skip a step because you're gonna be upset with me because you didn't follow directions. Okay. All right. So don't skip this step in here, in this lesson, okay? There's a reason why we're in this lesson. All right, some of you are trying to skip steps because you already know this. I understand you already know this, but you have to show it. Number 7. 2/3 x equal negative 8. 2/3 x equals negative 8. All right, there are a couple ways you could do this one. Now, notice a coefficient is a fraction this time, right? And so, if you think about it like we were thinking, right now, what am I doing to x? By 2/3. What's the opposite of multiplying by 2/3? Divide by 2/3. Okay? So you learned last semester how to divide fractions. So from last semester, when I had 3/5 divided by 2/7, let's say, how'd you deal with this last semester? You multiply by the reciprocal. So it's the top fraction, 3/5, times the reciprocal of the bottom fraction. What's the reciprocal of 2/7? 7/2, and then you reduce if you can, and then you'd multiply. I can't reduce here, so 3 times 7 is 21, 5 times 2 is 10. Okay? You're going to do the same idea here. That's one approach. So one approach is to divide both sides by what? No. What's 2/3? 2/3. So divide both sides by 2/3. And so 2/3 divided by 2/3 is what? 1. 1 times x is x. Now I've got to figure this part out right here, though. So my numerator is a negative 8. My denominator is what? 2/3. So I got to change this division to what kind of problem? Multiplication. So I get negative 8 over 1, because that's the numerator, times the reciprocal of the denominator. What's the reciprocal of the denominator? 3 over 2. And then we can either multiply first and then reduce, or we can reduce first and then multiply. Does not matter. So you are going to have fractions as you go through this course. So if I multiply first, what's the numerator if I multiply first? What's the denominator? And what's negative 24 divided by 2? Negative 12. Okay? If I were to reduce first, you'd say 2 into 2 is 1, 2 into 8 is 4, and what's a negative 4 times a positive 3? Negative 12. So get the same thing. All right, so the answer is x equal negative 12. Okay? So when you have fractions of the coefficient, one approach is divide both sides by that fraction, by that coefficient, but then you got to remember some things from a previous course. How do you divide fractions? So again, as we said, everything you've learned in a previous course comes back in here. Everything you learn in here goes to the next course. Everything you learn in the next course goes to the next course. Okay? All right, now here's another way you could do this. Now it's up to you which approach you use. I'm going to go ahead and write this over. All right, so remember, you want the coefficient of x to be what number? 1. You want the coefficient of x to be 1. Okay, so you remember, you see how I divided both sides by 2/3? Right? Dividing by 2/3 is the same thing as multiplying by the what? Reciprocal. So in my mind, I know that in order to get x by itself, in order to get this to be a 1, I need to multiply this fraction by its reciprocal. Because remember reciprocals, when we talked about reciprocals, the multiplicative inverse? If I multiply two numbers that are multiplicative inverse of each other, what product is it? It's 1. That was one of the things you had to turn in. It's 1. So I'm going to go ahead and rewrite this over right here. So in other words, if I want this to be a 1, then I got to multiply by what fraction? Not 2/3, 3/2, the reciprocal. But what I do to one side, I have to do to what? The other. All right, and then look, what's 3 times 2? And what's 2 times 3? And what's 6/6? 1. So remember, these divide out, and you're just left with 1x, which is what? X. Over here, it's a good idea to write this as negative 8/1, and that doesn't it kind of look like this right here? Doesn't it kind of look like this? See this right here? Can y'all see that? This is this. And so I can say, well, negative 8 times 3 is what? 1 times 2 is 2, and that's equal to what? Negative 12. All right, so one approach is to divide both sides by the coefficient, or you can multiply both sides by the reciprocal. All right, so let's look at one more like this. So let's say we had, let me go ahead and make this one up. All right, let's suppose we had this. Okay, suppose we had 7 6x equal, let's make that a 14. 7 6x equals 14. I'm going to solve for x. What's that one step you're going to show? You can do either one. What will be one step you can do? Multiply by what? 6/7. Okay, that would be one step. So in that space, you could say, we'll go ahead and rewrite this over. You can say times 7 6. I'm sorry, not 7 6, but what? 6 7ths, and then times what? 6 7. So what I do to one side, I have to do to the other. But you got to note that 6 times 7, this numerator, what do you notice about the denominator? It's also what? 6 times 7. And so anything divided by itself is what number? 1. So all of these are 1s. And all you're left with is what letter over here? X. Over here, you got to do some work now. So look at this. That's 14 over what? Now, you got to know how to reduce first. See, I don't want to multiply 14 times 6 first. It is quicker to reduce first. 7 into 7 is 1. 7 into 14 is 2. And all you're left with is 2 times 6, which is 12. There's your answer. Okay? The other approach you could have taken, instead of multiplying both sides by the reciprocal, the other approach you could have taken was to divide both sides by what? 7 6. And so 7 6 divided by 7 6 is what? 1. 1 times x is x. All right, now let's think about this side right here. How do you rewrite this division problem?
14 over 1.
Times what?
6 over 7.
Yeah, which is what this is. See, this right here is this, right? This is this. So reduce first. 77 is 1. 7 to 14 is 2. So what's the answer? 12. Okay, so all you do. All right. Now let's look at, so we did 7. Let's look at 9. All right, number 9. You have 1/6D equals 1/2. 1/6D equals 1/2. It doesn't matter what approach you take. You can multiply both sides by the reciprocal of the coefficient, or you can divide both sides by the coefficient. Does not matter. I'm not going to do both. I'm just going to do one of them. So which one do you want me to do? Multiply by the reciprocal? Okay. So let me go ahead and rewrite it over. So I want you to tell me what are you going to multiply the left side by then? 6 over 1, or 6, doesn't matter, but 6 over 1. Y'all agree that 6 over 1 is the same thing as 6, all right? But what I do to the left, I have to do the what? To the right. So that's what you need to show. That one step, you better show times 6 over 1 times 6 over 1, or times 6 times 6. Does not matter. But what you need to know is that this thing I have circled right here, that product better give you what number? 1. And it does, because 6 divided by 6 is what? Is 1. So this thing I have circled right here, that right here, better be what number? 1. And it is. So that's why you get an x, because 1 times x is x. 1 times d is what? D. Now you got to do this side. Now you can do this in your head. 6 times 1 is 6. 1 times 2 is 2. 6 divided by 2 is 3. But you could have reduced first, right? You could have said 2 into 2 is 1. 2 into 6 is 3. And you get the same thing. Does not matter. Okay? Does not matter. Now, let me go ahead and actually do the other way. If you had divided both sides, what would you divide both sides by? 1/6. Just like this, right? 1/6 divided by 1/6 is what? 1 times d is d. All right. Now, from last semester, how did you deal with this right here? You said what? Multiply by the reciprocal. So it's 1/2 times what? And isn't that what this was? Okay, so you get 2 into 2 is 1, 2 into 6 is 3, so what's the answer? 3. D equals 3. Okay, so that is. Let's look at 11. Okay, 11. A divided by 2 equals 1. A divided by 2 equals 1. See, the others, like number 9, that one was a little bit easier to do because you can actually see the coefficient. You can actually see this idea. 1/6 times d, right? You can see this right here. 2/3 times what? X. -1 times x, and so on. Here, though, you got to be careful. There is a coefficient. What do you think that coefficient is? Nope. It is not a 1. So that's where you got to do this now. Do y'all agree? Do y'all agree that, and you got to look at this, do y'all agree that this right here is the same thing as saying 1/2 times A?
No.
Yes or no? No? Okay. Let's see why it is true, though. Y'all agree that 1/2 times A is the same thing as saying 1/2 times A over 1? Yes or no?
Yes.
Okay. What's 1 times A? What's 2 times 1? You're telling me that that's not the same thing? Okay, so what you want to do here, when you have the variable that's specifically in the numerator divided by a number, and you're going to see this quite often, and see how some of you did not quite know what to do here. When you have a variable divided by a number, like it looks like this, you want to rewrite it to where you have that coefficient out in front. So this is really 1 divided by what? 2. 1 divided by 2. So the coefficient is not 1. The coefficient of A is not 1. The coefficient of A is what? 1/2. That's a coefficient. So get 1/2 A equals 1. And now you can go from there. Let's just do one part of it. Let's just go ahead and multiply both sides by the reciprocal. What's the reciprocal of 1/2? 2/1. So I'm going to say times 2/1 times 2/1. Y'all agree? Yeah. Now this thing I have circle, I want you to think about this. This thing I have circle, that product better be what number? 1. And it is, because 2 divided by 2 is what? 1 times A is A. And what does A equal? 2. A equals 2. So let's look at this one here. Let's do example. Okay, let's write this example. All right, suppose we had this. Suppose we had A divided by 3 equals a negative 2. A divided by 3 equals a negative 2. Now, there are several approaches you can take here. But for us, for some of you, you really need to write this as a coefficient times the letter, times the variable. So A divided by 3 is the same thing as saying what fraction times A? 1/3. So that's 1/3 times A. So I got 1/3 equals negative 2, and now I'm going to multiply both sides by the reciprocal of the coefficient. What's the reciprocal of the coefficient? 3/1. So times both sides, right? This thing I have circled, I want you to think about this. This thing I have circled, what is that product? 1 times A is A, and what's the answer? -6. That's all you do. All right. Now on that worksheet you got, there's one of them that has a decimal in it. So let's just do one real quick. So this is going to be number 15. Just to show you what to do on that worksheet. So this is 15. And it's very simple. You can use your calculator though. Use your calculator. All right. So I think it's the very last one. Number 11. Is it number 11? Kind of looks like this. All right, right now, what am I multiplying the variable x by? What's the opposite of multiplying by 1.7? Yeah, so just do this now. 1.7, 1.7, there's your step. You know that this is a 1. 1 times x is what? Okay, use your calculator. What's 10.71 divided by 1.7? 6.3? Okay, y'all agree? And that's all you do. All right. Okay, now the next class period, we're going to mix these operations. So notice in each of these, you either use the multiplication property of equality or use the addition. The next class period is going to be a mixture. It'll be a mixture. But in order to be able to do those, you got to understand what we just did in both of these. Okay? All right, so you should be able to do